Hello and welcome to the cognitive walkthrough to the application I developed during my master thesis, creating a model-driven methodology for creating and designing digital shadows. I will for a short time show the application to you, and after that I will show you the models I developed for that, and then continue with the DTOs, DTO loaders, and commands I've written so far. So let's log into the application, and you see I've added a new menu point here, and then in the top menu there's the digital shadow type, data trace, data points, model, workflow, assets, processing, and overview page. And basically these 7 menu points create the corresponding entity. So this dialog here allows domain experts to create a digital shadow type. Here data traces can be created and so on and so forth. And basically the assets and the data points can be imported using a class diagram. I can show you an example later on, and can copy this into the text area here and then create assets for that. Maybe we can start with doing so. So when I open the everyday assets here, this is one of the use cases I developed to test my methodology during the master thesis. You see this is like the CD files we are using in the Montigem applications, and then I just listed classes here and associations between these classes, and in the case I pass this, I can click on the overview page on assets and processings, and they are listed right here with the sub-assets. These are the associations and the attributes. This classes did not have attributes, but in case, for example, the fridge could have an attribute which is current temperature. This could be added, and then this would be listed here. So these overview pages show the already created entities for digital shadow types, assets and processings, data traces, and data points. The digital shadow types that are created can be exported here, such that a class diagram is formed, and the domain experts can copy this class diagram into the domain CD of another application and create the digital shadow instance there. So let's get started with the GUI models. I open my IntelliJ here, and I've started already the front end and the back end, otherwise we could not start the application. I will now minimize this so that the screen is a little bit bigger. So in the modeled section, I have created digital shadow GUI models, and all of these GUI models follow the same naming convention, which is digital shadow minus the entity that is created, or entity minus overview in case it is an overview page. So let's get started with the asset model, with the asset page. Just for remembering, this is the really simple GUI model which has just a text area here and then calls a command when the pass button is pressed. So this is the menu bar. Here are tabs defined for each the corresponding model is linked. So this should not really differ for each of these pages. Instead of like when having a look at the workflow page, the link is / instead of this one, and this link would then be / digital shadow asset. So in this case we define the container. So this is the card which is shown here, and this card then just has a label over here and a text area within class diagram. And here is the button, the pass button, which then calls the pass diagram method in the TypeScript handler. So the corresponding TypeScript handler is called digital minus shadow minus assets minus gen component ts. I just use the star here to not write this completely on my own. And this is an overridden TypeScript handler, so we are using the top mechanism here. If you do not create a class named like this in the front-end project, then the generated file would not be named digital/top, but just digital shadow asset gen component. So this is the template URL. This is the basically the name we gave the GUI model, and then this is the method which is called whenever the pass button is clicked. And as you can see, we just call the asset create command here, set the CD option of the command to the class diagram control value. This is the text area we have defined here. And then we add this command, send this command, and then reset the text area control so that this control is empty. This is basically the basic TypeScript handler with minimal functionality. We had to override this because the pass diagram method had to be overridden. Let's have a look at another example of an creation page, which is then not this basically because we really need information. So we cannot have a look at the model page because this is exactly the same as the assets. But if we have a look at the data traces, we have a name text field here, we have a source dropdown, and we have a data table filled with the data points on the really bottom. So let's take a look at the data traces. Digital shadow data trace gen component, no minus between gen and component, and it's working fine. So the first difference is that we have a formula here, and we query the data point with properties list. So this formula is used because we can select and unselect, or we can create and delete data points here. Let me import a class diagram so we can see this. So in the data points, I can click to show class diagram import. So we can allow domain experts to really import the class diagram here. And as you can see, we have class diagram with the classes and attributes here. So in case I import this one, you can have a look at the overview page, and these data points are shown here. And now for each of these data points, another entry is listed here, and we can delete this entry. This is important because we now can define, for example, an offer data trace here, and then we need to select a source. So the offers come from the internet, and the corresponding data point for the offer data trace is the offer data point. You can submit this dialog using return on the keyboard. And in case I press create here, I created a data trace with the corresponding data point. So let's have a look at the corresponding GUI model and see how we made this work. So this is the GUI. So as I told you, the formula is for using the delete button basically. The data point with properties list is used to fill the data table at the really bottom. Okay, this one is the navigation bar, we already noticed. And then we have a card here, nothing new. We have a text field, which is linked to a control in the TypeScript handler. This is the drop-down, again linked to the corresponding attribute in the TypeScript handler. And then we have the data table here, and the data table has an edit template, so we could try to edit something, but it's not editable. So here, this is the important part. So we have a row for each of the data points in the list. So this list has an attribute data point, which is basically a list of data points. And for each of these data points, we have those two columns, name and attribute. Link this to the name and the attributes file of the data points, and fill the table with that. And on the really bottom, we have the create button. So when taking a look at the TypeScript handler, we can see that we have the form here. This is actually linked here in the providers too, in the component annotation. And then we can see that we select the source full DTO get all. So these are all sources queried from the front end to the back end. And then we get a source full DTO list as a result. And for each of these options, we basically push this to an options array and set the options to the drop-down control. This mapping is just used to select the correct source ID for the command later on. Here's the create data trace method, and so that we select the source by its ID, and then we create a source DTO full. With this source DTO full ID, we create a source command here. This just avoids that the ID is being manipulated. And this data trace full DTO creates the data trace then. Sets the name, the source, and the data points. So basically, I've shown two different, I would say, input dialogues now. I would conclude this first section of the video with an overview model, because they are basically all the same. I will select the digital shadow types overview component for this, because this is the only one which offers a functionality and is therefore something special. Okay, we select our digital shadow type GUI list. So basically there's only one list which is filled with all entities. I will show you this in the section when I show the DTO loaders. Here's a data table once again. We have a right-click menu, which is a context menu. And this context menu has one entry export, and this export calls the show export dialog method. And this method, digital shadow types, selects the correct digital shadow type, then calls the digital shadow type export command, which is written by us, handwritten, and then selects the message that is returned by this command and copies this to the clipboard directly and shows a notification OK only. So this is like a dialog from which the user can copy it by hand. So at the end, We have shown the overview pages, we have shown some creation pages, and we should now continue with the CD files for that. So the really first step was to extend the domain CD with classes for each entity of the conceptual model, which was presented within the master thesis and which was provided by the group of the IOP. And basically, we have added a class for each of this for each entity in the conceptual model and added a name attribute so that we can identify this one in the GUI and easier access this without the need of showing IDs and remembering IDs. Another CD file we wrote is the digital shadow CD. Here are all classes contained that we needed for those overview pages, for example. So processing with properties list is basically everything that is shown in the UI when having a look at the overview page, and then asset and processing on the right hand side here. These are basically processing with properties. So each of these classes contained in this file, and then last but not least we've added commands over here. Asset create, data point create, and digital shadow type export are the three commands we need to write because the asset and the data points can be created using class diagrams. The digital shadow type export is basically the main aspect of our application because with the result another application can be built and the digital shadow can be really implemented and be running. So I now start with the DTOs and DTO loaders, not with the commands. As for reference, as remembering, we have written those DTOs by hand and added them to the digital shadow class diagram. So we had to override the DTO loader for this list class to create these entities at runtime because we did not save them in the database, as it is more complicated to get the linking between the original entity and the saved entity. So we have the assets here, asset with properties, and as you can see here we have the DTO, and next to this we have the asset with properties list DTO loader. Those classes are in the back end, so we now leave the front end part and just go to the back end. And basically the asset with properties is a mapping. So we extended once again the DTO top, the generated DTO using the top mechanism, and basically we added an asset with another constructor taking the original class, which is asset in this case, and then mapping the associations and properties to strings. So the name is basically the same because it was a string before, but in case you see the attributes here, which is attribute, which is a domain class, we map them to the string, in this case using the attribute type, a space, and the attribute name. So basically here we get string name as a result, and the sub-assets are mapped to the name as I said before. So this is the main purpose of the attribute name from each asset. The asset with properties list DTO loader is now called from the UI from the front end in case we open the web page and have an all asset with properties list DTO loader, or maybe an one DTO loader is just a question which of those methods needs to be called. So in case all lists are called, so this method is called, as a consequence, we return the asset with properties list, query all assets from the database, and map each of these assets to the asset with properties DTO, and then collect them as a list and set them to the assets of the resulting list DTO, such that the GUI database table can call list.assets to access them. For a specific ID, we implemented that the asset is queried from the database. In case there is an asset with this ID, we set this asset as a list to the assets of the list DTO and return this DTO then. And this is handwritten for each of the entity class. So we have assets, data points, data traces with properties, of course. And for the data trace, we just mapped the data points to strings, such that we can see which data points are connected to this data trace in the UI. We have this digital shadow type, have an ID, name, models, asset, and data traces here. We needed the ID for the export, so we can submit the ID to the command. If this DTO does not have an ID, we cannot identify the digital shadow type, or we would have to use a name which is not unique in the database constraints. Okay, after showing the DTOs and DTO loaders, I will continue with the commands and start with the asset create command. So the asset create command basically gets a class diagram as a parameter, parses this class diagram. We wrote an util for this, but just for code readability, because we used it at two different parts of the software. Then we had the problem that in case we have multiple assets with sub-assets in the class diagram, we needed to ensure that the sub-assets were created before the main asset is created. For this, we compared the subtypes, or the number of subtypes, and sorted for them, such that those assets with less number of subtypes are on the beginning. Nevertheless, we checked once again if the sub-asset is already created, and if not, we added the class to the end of the list and would try it again later on. And then basically the class diagram parse util has a class pojo. The class pojo has attributes, names, subtypes in the superclass. And then these attributes are attribute pojos, and this attribute pojo is basically once again type and name. So we can read the class diagram and parse it into classes and attributes without knowing whether we pass a data point or an asset diagram here. So for each of these classes, we create we read the attributes in, and for each of these attributes, we create a database attribute, and then create a class later on with the mapping to the created attributes. Then we save the created assets in a map, such that we can access the IDs to create an asset together with its sub-assets in the correct way. So this one is basically how to build an asset with sub-assets if present. The data points create command nearly looks the same. I would explain the shortcuts I'm using, but I'm using the Eclipse shortcuts, which is not the default. In case you do so too, Control Shift R opens the find class, and then F3 opens like the methods when hovering. I don't know the original IntelliJ shortcut for that, so I do not explain these shortcuts right now. Okay, we are in the data points create, and as you can see, the class diagram pass util is called again with the class diagram here, but the following logic is really similar. So the classes that are created here are once again then called for the attributes, and all these attributes are created. And after creating all attributes, we can create the data point and link the attributes to the data point. The most complicated logic for this application basically is the digital shadow type export. We handwritten the export into a class diagram, as it's not that complicated. And at the very first step, I select the digital shadow type. So I get an ID, and I resolve this ID to the entity. In the prepare data method, I then add all the assets that are contained, all the data traces, and for each of the data traces and sources, I add an asset and sources map. So in the export for a digital shadow type, assets, sources, data traces, processings are contained, but only those that are really related to this digital shadow type. In case I have multiple digital shadow types in the system, which is possible, we do not want all the sources in the class diagram export because it is not helpful. And then we had to select the correct assets and sources, for example by the originates from linking, which is from a data trace to a source, as well as the digital shadow type stands for an asset, and this asset may have subassets, and those subassets have to be contained too. So we started with a class diagram with the digital shadow type name. Then after that added the sources with a nice comment at the beginning. And for the sources, we check if they are an asset, in processing, or a source, because they have different attributes and may have additional. I'll just show it. If we go to the asset, for example, I have these subassets. Sources don't have subassets because it's not necessary and wrong in the conceptual model. So these subassets here are added, for example. Processings are added right here. And for each processing, we can say how data is connected. So they have associations to the input data and the output data, which are bold here. And then we added data traces. For each data trace, we had to add the data points that are connected to these data traces. And then we can print it in the console for easier checking whether the front end or the back end has an error showing the result or communicating, because, for example, the dot message is the wrong attribute for the resulting or whatever. So I just checked this within unit test at the beginning, and then the output is really helpful. And as you see, the return DTO is created and filled here, and then return. So this is the digital shadow type export, which is the basic, which is the longest class I've written within this thesis. And yeah, so to conclude this video, I've shown you the application with seven create pages. Two of them work within class diagram, which is asset and data point. We have overview pages, 4 of them showing data points, data traces. One shows assets and processings on the same page because they are they're working nearly the same. And then we have this digital shadow types, which allows an export on a right click on an entry here. Thanks for listening.